Hello everyone, and today I want to explain about the permeability test. There are two types of permeability tests: constant head permeability test and falling head permeability test. In the videos, I would like to explain constant head permeability test. Objective. The objective of this method is to observe the coefficient of permeability of granular soil in the laboratory to find the coefficient of permeability of soil. Permeability test. There are two types of permeability tests: a constant head permeability test and falling head permeability test. This video explains focus on constant head permeability test only. Now, I want to talk about the equipment they use in constant head permeability test. First, the permeability device. To cover the permeability device, that must have a complete set of permeability device, such as the mold to place the sample, the water tank, and require accessory that all complete set is called the permeability device. So you need a complete set of permeability device. And the next one is the cylinder, especially 1000 millimeter graduated cylinder is required. The next one is the clipper that need to measure the area and the length of sample mold. And the next one is thermometer. Thermometer is needed to determine the temperature during the laboratory test. The next one is the timer. We need to record the time during this laboratory test. I would like to talk about some theory. Constant head method is available for determining the coefficient of permeability of a granular soil, not for clay soil. It is intended for a granular soil. This permeability method is based on the Darcy law. That this described equation is the Darcy law equation, and the corresponding flow rate is such Q equal to KIA. Well, K is the permeability of soil, I is the gradient, and A is the area of soil sample. Then, the coefficient of permeability is computed as this equation. And this equation, K is the coefficient of permeability, Q is the quantity of fluid in a unit time, I is hydraulic gradient, H different height across the sample, H1, H2, and H3. This H1, H2, and H3 you can get from the left during the test. You can get during the test, and you can only from test this H1, H2, and H3. L is the sample length across, which is H measure L1, A2, and A3. You can get L1, A2, and A3 easily by measuring the sample mold. A is the cross-sectional area of soil must under consideration. T is click off time or discharge meter. Q is the discharge. So you can clearly see from this picture H1, H2, and H3 and L1, A2, and A3 from this figure. So this is the A1, this is A2, and this is A3. You can get A1, A2, and A3 by measuring and this pipeline difference from the mole, and you can get the height difference H1, water level difference H1, H2, and A3. This H1, H2, and A3 only get from that during the test. Procedure. Step 1. Fill the sample in the sample cube. Fill the soil sample in the sample cube. And step 2. Before filling the area, L1, L2, and L3 should be measured. You can get the area is this inner area of the tube, and A1, A2, and A3 you can get from the difference level of this pi cube. And this is as L3. Step 3. By using centrifugal pump, provide the water from the supply tank to the overhead tank in order to constant the water level of overhead tank. Step 4. When the water level of overhead tank constant, read the pressure height from the standpipe reading. Record this height in order to calculate different height. Record the height mean H1, H2, and H3. Step 5. Using stopwatch and cylinder measure bar, we will measure Q and T. T is the time that you mark H1, H2, and H3, and Q is the time when the time stack. Q is the distance that got from the time stack and N. From the Q and T, you can calculate Q equal to Q by T. Step 6. From the measured data, we will give the coefficient of permeability from above formula. From the formula I only explained from the previous slide. Calculation. This table describes the calculation. You should make at least three tests. If you want to do, you can get many times, but you must take at least 3 tests. L1, A2, and A3 are all the same because they can you guess from the simple cube. H1, H2, and H3 you can get the water level had different that measure during the test. And Q equal to Q by T you can get from the time in the test. And use this data, you can get the coefficient of permeability from the equation that I explained in the previous slide. So, based on the test number, you can get the coefficient of permeability, and the coefficient of to get the average coefficient of permeability, you plus all the test result and divided by the number of tests. Then, the coefficient of permeability at any temperature T is released to K20 in the following equation. So, you should measure the temperature during your test time. But the coefficient of permeability is based on the K20. So, we can get the K20 coefficient of permeability from this equation. KT is the you get from this. And then nu T by nu 20 is you can get from that table. And then you get the K20, and the K20 means the coefficient of permeability of soil. Viscosity coefficient Correlation factor T by T, based on any temperature, the value of viscosity correction factor are given in this table. Use this correction factor, you can get the K20 and then range or coefficient of permeability. If you get the coefficient of permeability during 101, your sign is clean given. Or if you guess 0.01 centimeter per second of permeability, your sign is cosine. And you get between 0.01 and 0.001, your sign is called the fine sign. And then city clay is the between 0.001 and 0.00001 centimeter per second. Less than 0.0001 is the clay soil. So you can divide it or you can classify the type of soil based on the K value that you get from the laboratory test. Thank you for watching. And don't miss to subscribe my channel, Engineering Knowledge Channel. Thank you. See you next video.